So I'm delighted to introduce Morten Lindberget, who is the VP of Sales and Marketing at CondAlign. And today, what a presentation title, Morten. Room temperature bonding of electronics and wearables and flexible applications with anisotropic conductive adhesives films.
A whole mouthful, yes.
Yeah, Morten, feel free to screen share if you want. Also, CondAlign is an exhibitor. I want to highlight this. They are in room B.
I'm good to go. Thank you.
The stage is yours.
Thank you for your introduction, Christoph. My name is Morten Lindberget, VP Sales and Marketing at CondAlign. Thank you for the opportunity to present for you today. Jump straight into it. CondAlign at a glance. We are a technology company developing ACF products, anisotropic conductive films, based on our patented technology. And we are based in Oslo. We are 17, 18 people approximately at the moment, doing here R&D, product design, qualification, and pilot production, which means we develop and produce this anisotropic conductive adhesive, which we use for room temperature bonding and flexible electronics here in Oslo. Excuse me. We testing it, producing it, and do market introduction now. We have an internal roll-to-roll line. Commercial volumes that will be available are approximately 10,000 square meters annually, which means the line itself has a higher quality, a higher capacity, but we use the rest of that for product design, R&D, qualification, testing. Therefore, we are also now in negotiation with the European contract manufacturing for scaling up, for flexible supply to US customers, and also for industrialization competence. We address applications and markets benefiting from our first generation products now to start with, which means limited scale applications, and secondly, scaling up with multiple clients and on similar products, and also broadening the portfolio. Then when I say applications and markets benefiting from this, that means primarily flexible printed hybrid electronic applications, which the topic of this conference is a part of. We say one technology, multiple applications. Excuse me. So we have the E-line patent technology, which we use for organizing and aligning particles in conductive films, or to make conductive films with what we call targeted properties. This is very well suited for large-scale industrial manufacturing, in this case for roll-to-roll coating lines. And this goes into a huge amount of different applications. Little about the technology itself. So starting on the top here, this is an illustration sort of showing how the film looks like with the conductive chains in the C-plane through the film. We have what we call adjustable pitch, which means that we can choose what distance will be attained in each film. What we will target for the first product is the one you see upright, is the E-line 100. And here we choose for 100 micrometer between these conductive chains, which also, when we go right to the thickness, the film will also be 100 micrometers thick. You see that the particles are arranged into chains, and that reduces the required amount of particles a lot. Normally, if you make an electrically conductive film, you put so much conductive particle in there, you reach a percolation threshold, and you have isotropic conductivity in all directions. You don't need that amount of particles, and the advantage of that I will come back to on the next slide. But also the polymer in between is also, call it free to choose, that provide the material properties like the adhesiveness and the softness, etc. And then particles, for conductive particles for the E-line 100 film, we will use silver-coated glass spheres. And on the adhesive surface, that means we have chosen an acrylic PSA as a polymer for this film. So on the right side, you see the microscope pictures on scale of the Eline 100. On